Welcome to Blooming Gardens Farm. These are our chickens that we use for laying eggs, and we sell the eggs through a small egg share. So yeah, the farm was started in 2008. We started with the big barn for the horses and the miniature donkeys, and it has since grown to be a chicken coop, the barn, and 3 high tunnel greenhouses. The one that we're about to go into is the one that the pigs live in, and that would be Thelma and Louise. And the anaerobic digester that we use inside the greenhouse actually takes most of the odor out of the space. So why don't you come down and see what we do down there, and we'll start with some breakfast made on biogas. We're here to prove a point and show you how the production of everything and the methane or biogas that's made in the greenhouse, outside of the greenhouse here, is all tied together. So what we have is basically the food production on the farm, and the animals that we raise here, and the crops that we grow hydroponically all feed into the waste that are recycled in an anaerobic digester where the biogas is created out back. So we have it piped in right now and turned on, so we're gonna go ahead and light the burner. Woo! Yeah, how about it? There you go, Ronnie. This is what we call our beastie digester. Basically, it's a concrete structure where food waste and manures go into this big tube over here on the side, and they go into there where it's mixed with water. This is where the liquid, or as we call it, effluent, comes out. So when you feed on the other side, that builds up a little bit of pressure, and out comes liquid from the top of the layers in there. And that tube feeds to the bottom. This one comes up about 2 feet off the bottom. And liquid comes out that's rich in nutrients. We call it effluent. There's some in that drum there. And that's what's applied to the fields to make the crops grow better. It's rich in micronutrients, a lot of molybdenum and manganese and things of that sort. So this is a constant feed system where raw manure and processed manures are all mixed together in one big bin. And there's a dome inside this top part that collects the gas, and the gas is piped down through these pipes and into the biogas bag. So this is the biogas bag that we got from Puchin in China, and a pump to pump the gas into the stove. And the green device is a sulfur scrubber that takes the sulfur out of the biogas that contains mostly methane, some carbon dioxide, and very little sulfur. The white plastic device here with the 2 green tubes, it is to take out any water vapor that might be in it. So it's a pretty simple elemental type of setup, but it works really well for a small scale like this. And if you can see in here, there's a little SD card in here that's recording the data. So all of our temperature data is logged every 15 minutes at a top position on the digester and a bottom position, as well as ambient temperature. And then we take this back to the office, and we can graph and log the temperature and see with these 5 digesters how cold does it get before it quits functioning, how long does it stay producing methane, and how does the temperature and temperate zones affect this whole system. Here we are at the back of our patented digester system. It's much different than the other one we just saw. This is a 40-foot, 36-inch diameter pipe. It's essentially a drainage pipe. And we've put in 120-gallon drums on their side. And then we cut a hole here so that materials can go in through that hole. We have found that the fertilizer that comes out of this system is richer than the fertilizer fluid that comes out of that system, but they're both really good. We're going to develop another system that we're working on that'll keep it at 145-degree temperature for a long period of time, a lower temp, longer term, and it'll be a little bit easier to do bigger volumes of the fertilizer for pasteurization. So this is basically a segmented digester, and that's what we have our patent on. This is the food waste that then goes into our digester unit. You can see this is stuff that would normally go into the landfill. So it's a good use for it. And it's really rich in nutrients. You don't realize how much nutrients are actually in the peelings and in some of the roots of things. These are untouched waste. They go right from their food preparation in the restaurant into these barrels. And we use 3 5-gallon barrels a week for both digesters, so it's not a large amount of waste, but you add it up accumulatively, and it's quite a savings at the landfill. Our goal is to set this up, the system that we have here. We're going to put this copper tubing inside this 55-gallon drum, and then this is an on-demand hot water heater from China, and again, we just don't have them in the United States yet. But basically, biogas comes in the bottom, it's burnt, and it will circulate like an antifreeze fluid that runs through these tubes. So it'll run through the bottom of this barrel, and we'll put the fertilizer in here, and we'll keep this at a longer time, retention time, at a lower temperature to pasteurize the fertilizer fluid, the base fertilizer fluid that we want to use. So that's the goals for the future. This is what we call our belly digester, because it's similar to the intestines of the human gut. And we have an inlet that would kind of be like the throat. We incinerate the food waste, so we get food waste from the local Boxer's restaurant in Huntington, and that is poured into this hole. The pigs that live inside this pen here to our left their feces comes in here down this chute, goes into this cap, the covered hole here, and it goes into this long tube into those drums that we talked about. So we put food waste, bagels, and farm manures in here. And that's what creates the effluent and also creates the methane gas, some of the biogas that comes out of it. This long tube has collection pipes that come off of it so that we can get samples for pH testing, for nutrient testing, and for temperature. So we are in the high tunnel where we ran some preliminary trials this year to test the efficiency of the nutrient fluid that comes out of the digester. These trials were all run with our patented belly digester system. And this basil here that you're seeing now had no applications of any effluent fertilizer whatsoever. It was grown up, harvested and weighed, and then it was chopped off at about 2 inches above the soil. This one over here had only one application of fertilizer at a dilution of 40:1, and the top growth was 40% greater than the basil that you saw a minute ago. And after we cut this also off at the same day and same time, this one was cut the same distance above the soil, and they've been now allowed to grow for 3 weeks without anything. So this is all only one application of the what we call root stimulator fluid, and the growth you can see is amazingly different. Pretty amazing what one application did for root stimulation. It's particularly really good for leafy greens, things like basil, kale, lettuces, collards. So we focused on those, and we also ran some trials on peppers and tomatoes this year as well.